Fantastic. Hi, everyone. I'm Hoi Lam from Google, and today I'm going to talk about the 4 steps of Android machine learning. If you want to ask me any questions, there will be time at the end, hopefully. But failing that, my DM, my direct message is open on Twitter, so you can follow me on Twitter at Hoitab, H-O-I-T-A-B. If you do want to get in touch in that way, just let me know that you have listened to this talk at droidCon Americas, and we will try to kind of come back to you with answers. So with that, let's switch over to the slides to begin with. Let's see. Yay! Okay, we have got slides. So the first thing that I wanted to highlight is, hey, why do we want to do machine learning to begin with? So the first thing that maybe we should review is how does machine learning differ from traditional programming? So if we think about the example of activity detection, where we want to differentiate between walking and running, we may do something like this and say, hey, if the speed is less than 4, then it is walking. If it is more, then it's running. If it is even more than that, it's biking. But we run into problems when we wanted to do something a little bit more general, something like, hey, detecting someone is playing golf. And one of the advantages of machine learning is that you no longer need to pick on particular features, in this case, speed for differentiating different activity detection, but instead you can use the full range of sensors that may be on your phone or devices such as wearables. So if we look at the traditional programming model, we will, as programmers and developers, put in the rules, and then we combine that with the data that is in that the user have input or the phone have detect, and then after that we give her the answer whether the user is walking or running. But in machine learning, what we try to do is, in order to come up with the rules, we give the computer both the answer and the data and say, hey, can you please find the code that stands behind the answer and the data, and then it outputs the rules. And once that rules is determined, then usually it will be feedback into the traditional programming model and then used in a conventional way. So in training, we will basically do the bottom half of this, and then in inference, in terms of actually using the model, we'll be using the top half traditional programming again. And in real life, it will look something like this, where we only need to feed the algorithm things like accelerometer data or gyroscope data, and it will make the correct categorization based on a number of factors, not just speed. So the second question is, hey, ML is great, but why do we want to run it on device? Maybe there are 3 different advantages of running machine learning on device. The first thing is privacy. So if the data stays on your device, then then you can enhance the privacy, and all the processing is done on device. Secondly, it can work offline. So it works in remote areas, including somewhere like the London Underground, where there is no connection. And last but not least, low latency. So this is the one that I'm really excited about, because you can work with the user in real time if you're running on-device machine learning. If you think about the round-trip kind of latency, even in the fastest, most ideal condition for the cloud, you're talking about maybe 100 or maybe even a couple hundreds milliseconds. Whereas on device, we can achieve 30 frames per minute in a lot of different cases, or maybe even higher, 60 frames per second, if the model is relatively lightweight. So this brings in a whole new class of use cases and scenarios that you can think about with the low latency. So for the rest of this talk, I will go through the 4 different steps of building for machine learning, from design to finding model, to building model, to actually implementing it in your Android app. So let's kick off with ML design. We launched the People plus AI guidebook at Google I/O last year, and this is a one-stop shop for highlighting some of the best practices that Google have learned. And I will encourage you to share this with your product managers as well as designers. And it contains a lot of not just lessons learned, but actually worksheets that you can work through with the rest of your team in design sprints, etc. So I strongly encourage you to forward this to your designers or product managers that you like. And next, so once you have determined that you do need machine learning, what is the next step? So the easiest thing is to essentially find a model that already works and just implement it. And there are three different places where you can find them. And I'll go through them in turn. The first one I'll go through is MLKit. So that's Google's machine learning SDK for mobile. And it is a ready-made library. It works just like any other SDK, and there's no machine learning expertise required to use it whatsoever. It's just kind of Kotlin and Java interfaces for developers here. And it builds on top of it is built on top of TensorFlow Lite, and it supports both Android as well as iOS. So if you find a functionality that you like and you want to code in not in Android, then you can potentially use MLKit as well. And starting this year, we have something that is relatively new. For those of you that have been using MLKit for a couple of years, you will know that previously it was tied to Firebase, but since the middle of this year, we have actually changed all of that so that for APIs that are running on device, i.e. is only using kind of the user's processing power and device, then we actually no longer require that Firebase sign-in and Firebase account. And now you can implement the MLKit functionality for on-device machine learning by purely just adding a line in your build.gradle file, and away you go. There is no more kind of messing around with the google.json file, etc. So it's really good. For the other APIs where you are using Google resource, so there's some cloud-based API in MLKit. We have migrate those into Firebase ML, and for those you will continue to need to use the Firebase account because you're using Google's resource, and if you get above a certain quota, then we will need to kind of charge you, etc. And as a result, that will need an account. But for on-device machine learning, which do not use Google resource, there is no need for the Firebase account anymore. And in addition to some of the offering that we have put in before that, this year we've also launched some new functionality, and I will highlight two of them. So the first one is the digital ink recognition. So this supports handwriting in over 300 different languages, including things like emojis and also basic shapes. So if you draw a pizza, then it will basically tell you it is a slice of pizza. And this may be a really fun game to kind of play with the rest of your development team. It is powered by the same technology as Google Gboard. And as you can see, it doesn't just use the static image that the user draw, but it actually detects the different strokes for as the user writes. So this get away from some of the problems that with traditional OCR or optical character recognition, whereby you don't know which character comes first or which words comes first. But in this case, for example, I'm writing in my native Cantonese or which is traditional Chinese, it was able to detect the different order of the character and then put it all together. So this is something that has an advantage over OCR if you're thinking about detecting users' handwriting. And like all the other MLKit APIs, it runs fully on device and is offered at no cost. The data that the user put in is not sent to Google. And everything is kind of basically respect the privacy of you as well as your user. The next thing that we've launched is around post detection. So it detects about 33 points skeletal match. And there are two different versions of the model, the fast and the accurate. So you can choose which one you want. There's a bit of a trade-off between model size as well as performance. And one of the things that surprising thing I would like to add is that when we first started, we thought, hey, we might need like a 3D depth model in order to do a lot of things that we want. But actually what we find is that you can find out a lot of information by just looking at the 2D distance between the different joints. So you might want to start with, between the ankle and the knee, and the kneecap, and then maybe adding the thigh if it's really required. And by just doing that, we find that in a lot of cases you're able to count the different reps of exercise that the user is doing. So if you have that requirement, I strongly encourage you to have a look at that, kind of just using 2D joint distance instead of maybe training a model kind of to run on top of the output of the post model, as being something that may be slightly easier to do. And again, just want to highlight, I sound like a broken record, but it's really important to highlight that everything is running fully on device and is offered at no cost. To find out more about these APIs, as well as all the other APIs, you can go to g.co/MLKit. The next thing that I want to highlight is ML-related APIs that is available on the Android platform. And like last year, I've spoken about both the text-to-speech as well as the speech recognizer API. Both of those have been in Android for a long time, so these should be available to all your users for practical purposes. And I wouldn't go through the presentation kind of back then. If you want to find out more, at Google I/O last year, I talked about how to use the speech detection and the voice recognizer in that particular presentation. But one thing that I do want to highlight is the very wide array of languages that these APIs do support. So as I said before, I come from Hong Kong, and we speak a slightly different version of Chinese, which is Cantonese, and that is supported, is spoken by 7 million people in Hong Kong, maybe in wider China, maybe about 60 million. So it is a sizable language, but it is definitely not a very kind of extremely popular kind of language in terms of speakers. But that language itself is supported. So I strongly encourage you to try it if you have that need. Yeah, so please go and check out the video from last year's Google I/O if you want to find out more. Last but not least, TensorFlow Hub. So TensorFlow Hub is a large repository of TensorFlow model from both Google and the wider research community. And for mobile developers, the section that you'll be interested in is this one. Under TF Lite, which stands for TensorFlow Lite, are the models that are optimized for both mobile as well as Internet of Things devices. So these graphs have been optimized to run on these form factors. And once you click on it, the link, then you will basically see all the different models that are available to run on Android and other mobile kind of platform. And so this is one way to get access to those models. You can browse through them. But my favorite way is to basically just use the search bar at the top. And you just kind of try to search and say, hey, I want a bird model, or I want an insect model, or I want a supermarket goods model. And that brings me to some of the latest update to TF Hub in terms of the model that is available. Here, I want to highlight a couple that we have uploaded in June as part of the industry conference for image recognition. So previously, these kind of models, which have, say, 100,000 different classes, or in the case of wine label, 400,000 different classes, these kind of models can only be run in the cloud because of performance reason and also because of the size of the model. So we have really shrunk it from multiple gigabytes down to, for the supermarket goods, about 40 megabytes, and for the wine label, about 140 megabytes. So these are still relatively large for the mobile use case, but I'm just really excited by the fact that they are available at all for mobile. And also, it is something that you can potentially ship with dynamic asset or dynamic feature delivery via Google Play as well. So if you have these kind of use cases, please go and check it out, and yeah, let us know if it works for you. So just to highlight, these are the 3 places where you can find ready-made models. So MLKit with the ready-to-use APIs, Android platform with the voice-related and speech-related functionality, and then for TensorFlow Hub for some of the latest Google and community models that you may be able to use. So that's finding the model. But what if you can't find the exact model that you need, and you really need to customize the model for your own use case? So the next thing that we have is essentially training a model. But training a model from scratch and determining the architecture is really hard. So what we have done is we have created some tooling for developers that you may be able to kind of use and follow. So the two solutions I want to kind of quickly run through, one is Firebase ML and the other one is from TensorFlow with the model maker library that they have. So with Firebase ML, a lot of you would have known, so we launched it, I think last year, maybe the year before, whereby there was a graphical user interface that you put in a bunch of photo data set together with the label. You essentially ask Firebase to train your model, and then after that, you can either use Firebase to serve that model, or you can just download the TF Lite model and integrate it with your mobile app. And the graphical user interface looks something like this. You just upload the model together with the photos, the source photo together with the label, and you just click on train model. And after that, you basically get a trade-off between the different versions of the model. Things like, hey, do you want it to be smaller and faster versus kind of more accurate and bigger models? So you can pick and choose whichever one, and everything is done through a graphical user interface. There is zero programming required for training the model in this way. The next one is a little bit more involved, but it is really quite easy once you if you follow the instructions. So the TensorFlow team have created the TensorFlow Lite Model Maker, especially targeting developers that understand code, but maybe not experts in machine learning. So these different types of trainers are available under this link at tensorflow.org/lite/tutorial. And I'll run through maybe two of them to just give you a taste of what they look like. So the first one is, of course, everyone does it, image classification, where you can follow the different Python code and line, etc., to in a step-by-step guide to upload or maybe train locally images and label, and then basically get a TF Lite model at the end. One of the options to run this is via the Google Colab. So that's the leftmost button over here. If I could kind of circle that. See my cursor. So and once you click on it, you basically can use a cloud instance in the Google Data Center, and it's able to kind of basically just run through the different lines of code without going through any of the Python setup. And that is something that I actually find really intuitive to use and easy to use, number one, but also quite powerful. So if you select the GPU acceleration option for using Google Colab, I find that actually the instance that we serve for free is actually faster than my workstation at work, simply because they have more GPU memory in a lot of those instances. So even in high-performance kind of training, for high-performance training purposes, you might want to check it out. The one drawback is because those instances are offered for free. Mostly, you can also buy like a premium version of it. It does time out if your particular training process run for a long time. So just keep an eye on that. But for a lot of these examples I'm giving you, those should work as is. So that's image classification as being the first example. A second example, which is really new, is around question and answer. So last year we launched a natural language processing model called BERT, B-E-R-T, and in the first instance, the model itself was too big to be run on device. But after that, our team got to work, and we have launched a mobile version of that model. And one of the things that it can do is you can provide with a passage, and then you can provide it with a question, and it will highlight the answer from the passage for you. And I use it over the weekend with my daughter's kind of comprehension exercise, and it was working great in some instances. It still got some kind of rough edges around it, especially with kind of data that are that you're asking for, or extension to kind of details are not in the passage. Those it still have problems with, but by just using it, you will be able to sense kind of what it can and can't do. And another thing that you can do is to actually train the model with your own question and answer. So this is really for developers that have specific knowledge in a particular domain. So let's say, maybe in a particular type of engineering, and you wanted to feed that into the model, then what you can do is you can come up with your own question and your own answer and feed that into the training, into the model maker kind of code, and then it will basically train a customized version of the TF-Lite model for you. And yeah, just kind of let me know if how that is working for you. I'm really super excited about this because I think natural language processing is one of those things that I really want to get done right, and I can see a lot of potential. But this is the first time when I can actually use it in such a elegant and user-friendly way. So that's the model maker. So just to sum up, there are two easy ways to train your model. The first one is the graphical tooling from Firebase ML if you want to train an image classifier. And then for a variety of different models, including natural language processing, then you can go ahead to the TF-Lite model maker and use the Google Colab to train your model. So once you've got your own TensorFlow model, how should you bring it into your Android app itself? So here we have three options: MLKit, the TensorFlow task library, as well as a new feature that we've launched in Android Studio called ML binding. So I'll briefly go through them in turn. So with MLKit, one of the key feedback that we got from before was, hey, your models are great, but what if it doesn't quite fulfill what I need and I need to change the underlying model? So what we have done is we have enabled a custom model to be fed into two different use cases. So one is image labeling, the other one is object detection and tracking. And in terms of why you want to do this, let me give you a concrete example. So in object detection and tracking, we by default actually have these 5 categories that you can filter. So, for example, if you're selling furnitures, you might want the user to point at various furnitures and be able to classify them and say, hey, what model they are. And but one of the problems that we find is if your particular design is very, very distinctive, then it might not fulfill basically what our model think of as furniture. And as a result, they might not detect that kind of goods. And what you can do is to actually train your own classifier and tell us what your furniture look like and plug it into the whole flow of object detection and tracking. And we can help with kind of all the pipelining and all the image kind of running the actual image coding. And all you need to do is to provide us with the TF-Lite file. So how does this look in code that is different compared to the normal object detection and tracking? So the first thing is you will basically define a local model and feeding in the TF-Lite model kind of name under the asset directory. And then secondly, you feed that local model object into the custom object detector option. And then finally, when you get an instance of the object detector, you just feed in the option that we've just specified. So it is really easy to specify your own model for use in this case. Next is the TF-Lite task library. So this is something that we have only recently launched in late summer, where you can essentially use it for a bunch of specific tasks, including image classification, but also other things like text classification and question and answer. Because one of the feedback that we've heard is, yes, thank you for the TF-Lite model, but for the Q&A scenario, it's still really hard to integrate because you still need to pass all the string into a bunch of byte array and then feeding it in and running the model multiple times. And I'm not quite sure how to do that. And if in the middle of it there is an error, then it doesn't work. So we have actually created a bunch of task library, and these same task library are being used by Google's own internal team to essentially wrap their own model and use in production. And it supports both Java language as well as C++. And right now, it only supports a CPU single thread. But going forward, we are looking at acceleration. One word of warning is that this is a nightly build at the moment. So this is still in kind of beta/preview mode. So if you do decide to use it, and especially if you decide to use it in production, then I would strongly encourage you to download a version that you're happy with and use that and not essentially download the nightly build just in case it breaks. But as I said, many of these code is actually used in production by Google. So the underlying code I'm actually pretty confident about. It's just that the complexity of the build process and maybe some code submission. You just want to protect yourself from that if you want to use it for production purposes. So just to give you two examples again, the image classifier where you can see you could basically feed in the image itself and then basically get the result back. So if I look at the Java API at the bottom, you just create the option, create a classifier, and then feed in the image to get the result. And for BERT, it's even easier. Again, looking at the Java API at the bottom, where you have the get an instance of the answerer and feed in the model file itself. And then after that, you basically just put in the context string and the question string. So the context string is the passage that you want to kind of ask question about, and then the question string is your question, and it will all pop the answers in a list. So that's something that you may want to check out. Last but not least, Android Studio 4.1 actually introduced a new function called ML model binding. So this idea actually started 2 years ago at droidCon Berlin when I was trying to create this particular demo called Hoi or Not. And when I was doing that, I realized that there's a lot of rough edges around integrating TensorFlow model. So first of all, there is a lot of code. There's a lot of boilerplate code that you need to get through in order to translate images into byte array, and then when you get the result back, it's also quite difficult to sometimes understand the output and basically match it up with the label file, etc. And if you get any of those wrong, then you essentially run into a number of exceptions that are, at least for me, as a starter, it was quite difficult to pass. And when I run this problem by other people that have done it, a number of times, they say, hey, each time when I do it, it's still a problem because I don't do it every day, and each time I do it, I need to kind of go back to my old code and try to copy and paste different aspects of that code into my existing project, and then when things don't work, it basically take half a day or a day to basically debug them, even for people that know how to do this. So I thought, hey, maybe we can do better than that. And as a result, both the TensorFlow team and the Android team came together, and we created ML model binding. So the new flow that you can get through is by just right-clicking on the module where you want to add the model, and just click New, then Other, then TensorFlow Lite model. After that, you specify the location of your model at the top, and then you can tick the box and say, hey, just add in all the dependencies for me. In addition, at the bottom, there is also an option to add in the code that is necessary for GPU acceleration. So if you want to experiment with that, then tick the second box as well. And after that, you will get to the user detail, the model detail kind of page on the where the code normally is. And the most exciting feature for me is this bit at the bottom, where you can just copy and paste some code, some sample code, and use it straight away. And there is basically no need to learn the different intricacies between quantization or normalization, because you could just we can read a lot of that from the metadata from the model, and we'll use that as we transform your image into the correct size and in the correct number format, and all that is taken care of for you. So if you want to try it out, then I strongly encourage you to take a look at Android Studio 4.1, and you can download it from this particular URL. So just a quick review of all the options: MLKit, the TensorFlow task library, as well as the Android Studio ML binding. So it can get a little bit confusing regarding kind of the different options. So I just want to quickly run through what you should choose and some of the high-level consideration that you might want to kind of run through. So first of all, the three different solutions do not support all the different scenarios. So here at the high level, these are the scenarios that they do support. And then the first thing that you might want to consider is the production readiness. So like I said, MLKit have been around for a couple of years, and then ML model binding have just turned production, whereas the TF-Lite task library is nightly. So in terms of production readiness, it's basically in that kind of order. The MLKit being the most production ready, in addition to the TF-Lite interpreter, which has been running for the last couple of years since the start, really. And that's something you need to consider. That's not to say that the TF-Lite task library, like I said, is not production ready, because the underlying code is used by Google in various products. But because this is a new library that we have launched, so we want to be a little bit cautious, and also because this is on a nightly build train, so you might also want to consider that as you consider how you import that library into your project. Second thing is C++ support. So if you want to program C++, I'm afraid the only option for you is the TF-Lite task library or the TF-Lite interpreter. So that's something to consider. And last but not least, hardware acceleration. So at the moment, the ML model binding as well as the TF-Lite interpreter do support acceleration. The TF-Lite task library as well as MLKit, at the moment, both teams are looking at how they can support hardware acceleration, and hopefully we will basically come back out at some future day to tell you that that is available. But for today, hardware acceleration, you need to choose either ML model binding or the TF-Lite interpreter. Another confusing thing for people is the difference between image classification. I certainly have it, and I asked this question to the team. It's like, hey, when should I use image classification and when should I use object detection? Because they both sounds really familiar or similar. You're giving them an image, and then out pops the probability of that image being different things. And the consideration here is really about how much of the screen does the object of interest takes. So if you're thinking about having a scene, for example, hey, the difference between a forest and an urban area, then yeah, you can use image classification, because the image that you're trying to classify essentially takes up the whole screen or the whole camera picture. Whereas if you're thinking about, for example, a shopping scenario where you go into a supermarket and you have goods that are standing right next to each other, then you might want to actually use object detection and tracking in order to crop to the particular area that you're interested in, and you can show the user that, hey, this is what I'm trying to detect, and then give them the feedback and say, hey, this is a carton of milk from this particular brand, etc. So that's something that the two scenarios here. One is detecting scenes using image classification, or if you have a very busy picture and you want to only detect parts of that picture, then I would strongly suggest you kind of consider object detection and tracking. And if we drill a little bit deeper, there are two ways to actually do object detection and tracking, and they yield different results. So with object detector and custom image classifier from MLKit, what it does is it tries to detect a generic object, and then it does two things. It runs two pipelines. So one is going through the image classifier for a static kind of single image. And then the second one is a generic tracker. So it basically follows the object around. So as you can see on the left, with that seagull, basically the boxes change, but the percentage doesn't change, because it doesn't actually run the image classifier on every single frame. If the tracker continues to maintain the tracking, it actually does not run the image classifier again. Unless it loses that tracking. So that's something to consider. Another way to do object detection is basically on the right-hand side, where you feed in a single shot image, and on every single frame, you try to classify the different objects. And as you can see, the percentage change on every single frame. And sometimes, for example, the keyboard kind of go in and out of detection, and that's perfectly normal. So that's something that can happen with a single shot detector. So in real life, which one should you choose? If you are thinking about a live use case, i.e., you're trying to feedback to the user in real time, kind of what is happening and using it in a streaming kind of video mode, then I would strongly suggest that you try out the ML-Kit object detector way, because it doesn't run the classifier on every single frame. It actually is relatively performant on, say, mid-range kind of devices or slightly older devices. Whereas with the single-shot detector, because it is running a detection on every single frame, that can get quite difficult on the mid-range device. But having said that, if you have an asynchronous flow, so for example, the user taking a picture and all you want to do is to detect a different object, and suggest different hashtags, then you might be able to use either one is fine, because that in that use case you're not looking for that 30 frames a second or 60 frames a second. What you're looking for is just a one-off processing, and either case is fine. And also in reality, the other thing to consider is the availability of the model. So if you're in prototyping and you find the model in either one, in either format, and you just want to use it and check it out, then hey, take the model that you have, rather than maybe training it for the most ideal scenario, and then you might want to change in the production environment. So that's basically the summary between the three different ways of integrating a TF-like model into Android, between ML-Kit, ML model binding, as well as the TF-like task library. So with that, those are the 4 steps of integrating machine learning into your app: design, find, build, and implement. And if you want to find out more with some of the details, there is a blog post which summarizes the 11 weeks of Android at this link. So it's goo.gle/MLWrap. So, and with that, that's all my slides. I'm open to questions. And yeah. And if I don't get to your question, please just ping me over DM on Twitter. So in case when the data, first question, in case the data will be collected from the user flow over time, do you think training the model on the mobile device is feasible? So yes, it is. Training on device is possible. But at the moment, I would argue that is a relatively advanced use case. There is a discipline, which name I briefly forgot, which is essentially you're trying to train the model over a large number of user devices, and then getting the result back, and into a central server, and trying to improve the model in a very distributed way. And in that technique, there are certain difficulties. So for example, you want to protect the user's privacy, and Gboard, for example, does this, which is when you try to detect kind of certain words that you're typing on the Google keyboard, or we're trying to kind of improve on the swipe gesture. What we do there is to try to train a little bit on the device, and then only send the delta back to the server, but with a lot of noise. That is to protect user privacy, and you can't kind of go back from the data that's submitted to the server back to the conversation that the user have. And but that is a very kind of advanced topic. There are tooling that are available, and I'll post the link, the TensorFlow link for that, after the event. And at the moment, those toolings are, I would say, a collection of tools rather than something that is really super joined up that you can just run kind of step 1, step 2, step 3. So if you are interested in those use cases, yeah, give me a ping, and then maybe we can talk a little bit more over DM. Okay, so any use case for post detection used in sample/production production apps. So sample apps are relatively simple. You just detect it and display it on screen. But in terms of use cases itself, so we highlighted maybe two in that particular slide that I put up. So one is to detect whether the user is, for example, touching their face. In the current time, that is a relatively useful kind of use case, and you can do that very easily. Secondly, is to count the number of repetition that the user have done on exercise. We have also found that some developers have used it to detect whether the user is doing the correct yoga poses. So it basically detect where the joints are and say, hey, this is this pose. And the more even more advanced use case will be saying, hey, have you done it correctly? So that's something that you might want to kind of try out if you're in the exercise kind of sector. Next, if I want to capture images and then detect objects later, how do I detect glare, shadow, etc., to make sure that the user limits this? So one of the ways that you can do this is to essentially have a lot of those bad photos as well as some good photos, and essentially train a classifier that you can run while the user is capturing the image. So you might think of, for example, if you're trying to detect plant disease in rural areas where you may not have connection, then you can have say Cambrix flow running together with an analyzer. And in that analyzer, you will try to detect whether the image is captured correctly, or there's glare, or there's not enough light. Those are just different classes, a little bit like the different types of flowers that I show. So that's definitely something that you can work on very easily. And with that, I think my time is up. If I didn't get to your question, please just ping me a DM, direct message on Twitter. My handle is Hoitab, Hoitab. All right. Have a great conference, guys. Bye.